Alright guys, so far in this chapter we've talked about arithmetic sequences and arithmetic series. We've talked about geometric sequences, and today we're going to start looking at geometric series. So today we're only going to look at a finite geometric series. Okay, and if you recall, a geometric series is similar to a arithmetic series in which it's a series where you add up all the terms. Okay, so we're going to be adding up all the terms of a geometric sequences, just like an arithmetic series was adding up all the terms of an arithmetic sequence. And what you're going to find is that this formula here, this one right here, is kind of the common sense formula. It simply says add up all the terms. So notice the partial sum, S sub n is the partial sum. So it says take a sub 1, the first term, and then the second term would be a sub 1 times the common ratio. And the third term would be the first term times the common ratio twice, and so on. Now there's another formula over here. So this guy over here, he is not quite as common sense, but it just says to take the first term and then multiply it by the ratio of 1 minus r to the n power over 1 minus r. Now please do not think that you can cancel out 1 minus r. We cannot do that here because the r has an n power and the 1 does not. So there's no factors there. So we have to keep the formula as it is. Now I am going to show you where this formula comes from. Okay, so we're going to derive the formula. To derive this formula, we're going to start by using the common sense formula, the original formula. So it says take a sub n equals a sub 1 plus a sub 1 times r, and so on. And the first step in actually deriving this formula is to take and multiply the equation by negative r. So we're going to take this equation here and we're going to multiply every single term by negative r. So negative r times s sub n would be negative r s sub n. Negative r times a sub 1, we could say negative r a sub 1, but because all the other terms are a sub 1 then r, I'm going to say negative a sub 1 r. And hopefully you see the reason behind this is because this would then cancel. But we're going to first continue multiplying. So negative r times a sub 1 times r would be negative a sub 1, and we'd have r squared. And then if we multiply negative r by this again, we'd have negative a sub 1 r cubed. And so on, until we would then have negative a sub 1 r to the n minus 1. And then if we multiply this term, negative a sub 1 times r to the n. And the reason we need those two terms is because I wanted to see that this one canceled, but if we really multiply a sub 1 times r to the n minus 1 times negative r to the n minus 1 times r would be r to the n, okay, because you would add 1 r to it. So now what we're going to do is we're going to actually cancel out like terms. So this guy cancels, and so on. Everything in this ellipsis is going to cancel, and that as well. So what we are left with is s sub n minus r s sub n. We can't add them, they're not alike, equals, well, we still have a sub 1 up here, so a sub 1 minus that last term down here, a sub 1 times r to the n. And we can kind of start seeing this emerge a little bit into our formula, but it's still not quite there. So the next step is to actually factor out any greatest common factors on each side. So on the left, notice that there's an s sub n in common. So if we take an s sub n out, we have 1 minus r. We're simply factoring. Now we're going to do the same thing on the right side. We're going to take out a sub 1, leaving us with 1 minus r sub n. And now we can see that this is starting to look like our formula, because the next step would be to divide both sides by 1 minus r. Now again, we can't just cancel these because they're not the same factor. So we would have s sub n equals a sub 1. Now I am going to split this apart. So I'm going to leave a sub 1 out by itself, and I'm just going to put 1 minus r to the n over 1 minus r, because we can put them together, okay? And this right here is the formula up there. It's just a derivation, it's been derived, sorry. Okay, so that's where it comes from. You need to memorize it. So make sure you know this formula right here. This guy right here, he's important, so that you can use him. So now let's actually work with the formula. So let's start with number 1 here. So number one, we're given 4 terms in a series. So the first 4 terms, and they say to find the partial sum of the 6 terms. So add up the first 6 terms, S sub 6. So what we're going to do is we're going to use our formula. So let's write that down first. S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. You might be saying, well, Miss Miller, I could just figure out the next 2 terms. And yes, you absolutely could. In fact, I would encourage you to do that to check your work. But you've got to know how to use the formula. So we're going to start with some small numbers, because if I said what's the partial sum of the first 50 terms, you're not going to do that by hand. You're going to use the formula. Okay? So if we're looking for the 6th term, so S sub 6, well, we can clearly see that the first term is 256. So this guy right here is my first term. So 256. Now I do need to find my r. So to go from 256 to 64, in case you've forgotten, you can simply divide the second by the first, but you should see that it's 1/4. Okay, it's dividing by 4, so it's going to be 1/4. So we're going to have 1 minus 1/4 to the 6th power over 1 minus 1/4. And yes, you may also use decimals here as long as they're precise. In fact, the decimals might have been a little bit easier to work with, but I wanted you to see how to work with the fractions. Now, if you really want to, we could simplify this down a little bit. There's no need to do it, but I will do it a little bit so you can see. I can't subtract 1 minus 1/4 because of the power. Order of operations says do powers before subtracting. But I can subtract the 1 minus 1/4 on the bottom here if you really want to. But again, you do not have to do this. In fact, I would just use the calculator. So looking at our calculator, we are going to type in exactly what I have written here. So 256, parentheses, remember alpha F1 is my fraction button, 1 minus, whoops, oh, click happy there, sorry, 1/4 to the 6th power over, and we can either write 1 minus 1/4, or we can just go ahead and write 3/4. Okay, and it's kind of nice that we have these little fancy calculators because we can write these fractions in here without being too problematic. So notice this looks exactly like what I have here on my paper. So we're going to hit enter. We get 1,365 over 4. If you really want to see the decimal, all you have to do is hit math and then decimal. And so we can see that's 341.25. So 341.25 would be the sum of the first 6 terms. Now we can check this. 256 plus 64 plus 16 plus 4 plus the next term will be 1. That's the first 5 plus 1/4, so 0.25. Same answer. Okay, and it really didn't take up too much time to do it this because there's only 5 terms to do this by hand. But again, if there were many more terms, you may not want to use that. You need to know how to use the formula, okay? So what I would like for you to do is I would like for you to try number 2. Now, if you notice, they don't give us a sequence. They don't give us the series written down here. But they do tell us the first term in the common ratio. And really, that's the only thing you need to know to plug in our formula. Just go ahead and take a minute and try this on your own. And when you're ready, turn the video back on. All right, guys, so the answer is 155. So the first 5 terms added together is 155. I used my calculator to calculate this, but again, you could have done this by hand. You could have come over to the side here and said, okay, I got 5 as the first term, multiply by 2, and so on. And then you could have just added those terms up. Either way, you get 155. Okay, so whenever the numbers are small, definitely check by hand just to make sure, but know how to use the formula. All right, number 3. This time we're looking at a summation. So we did these back when we looked at arithmetic series. So we know that this says that we're adding the first 10 terms. So we're starting at term 1 and adding up to term 10. And this here is going to be how we find our term, 2 times 3 to the n minus 1. And notice it looks very much like our geometric sequence formula. It's because it is. It's how we're finding the terms. So we could sit here and say, okay, a sub 1 is going to be 2 times 3 to the 1 minus 1. This is how we do this by hand. You need to know how to fill these in by hand if I ever ask you to. So 2 times 3 to the 0 is 2 times 1. A sub 2 equals 2 times 3 to the 2 minus 1. So 2 times 3. Just make sure you understand the skill, okay? Now, we're not going to do this for 10 terms. That's a little ridiculous. Okay, but you should be able to do it for a few terms just so you can make sure you know how to do it. But we're going to take this and we're going to use our formula because, again, a formula is, we have them because they're useful. They're quicker than trying to do things by hand. So if we fill in our formula, we're going to fill in S sub, well, we're looking for the 10th term, right? S sub 10 equals, well, we know the first term. I can see it here, but I can also see it right there. That first term is 2 times 1 minus, well, my common ratio, we can see that we're multiplying by 3, but you can also see it right there. That's my 3. So the formula gives us everything we need. So 1 minus 3 to the 10th power over 1 minus 3. So again, at this point, we're going to use our handy dandy calculator, type it in. So so make sure you're doing this with me. If you have a calculator, please don't let a calculator be the reason you miss a problem. So when we hit enter, we get 59,048. That's quite a large number. Now, we could continue doing this by hand to check it, but remember we can also do a summation on the calculator, which is particularly useful. So in case you've forgotten to do this, we hit alpha F2, and then notice it's my option 2, and then we type in what we want to use. So I'm going to use x. So x equals 1 up to 10, and then we're going to do 2 times 3 to the x minus 1. So make sure it looks exactly like that, except the x's and the n's are changed. Look at that, I got the same answer. Okay, so we just have different ways of finding our answer. One way might work better than another. Okay, and we have lots of ways to check, so make sure you're doing these correctly. All right, so number 4. It says find the sum of the series 2, 8, 32, and 1 plus 128 plus 512 using sigma notation. So we're going to actually change this back into its sigma form. So the first thing we have to know is that we are adding the first 1, 2, 3, 4, 5 terms. So I'm going to say n equals 1 up to n equals, actually we just put a 5 up there. We don't put n equals. I get a little. I like to write equals. So 1 to 5, just like so. Now, it doesn't matter what letter you use. You can use any letter you want. You can use X. You could use I, J. It doesn't matter. Okay, as long as you're using a letter. And then we have to come up with a formula. Now the formula is going to come from knowing the sequence. We know it's a geometric sequence because we can see to go from 2 to 8, if we just wrote the sequence, we would change the pluses to commas, and we can see that it's multiplying by 4 to get to the next term. So I know this series is definitely geometric. So to write the formula, we'd say, okay, a sub n, the first term is 2, the common ratio is 4 to the n minus 1. So we would simply have to write here 2 times 4 to the n minus 1. So this right here is the sigma notation of this problem. Now I do not need to put parentheses. I can, but I don't have to. And the reason being is because this just represents a term. Okay, you have to put parentheses when it's pluses and minuses, but when it's multiplying, they stick together. Okay. Now we do have to evaluate it. We could add these up. Okay, or we can use our calculator. So we're going to use our calculator just to get good practice. So alpha F2, option 2, we're going from x equals 1 up to 5, and 2 times 4 to the x minus 1. So we end up with 682. Again, we can count to make sure. 2 plus 8 plus 32 plus 128 plus 500. Whoops. Helps if you type it in the right way. Notice we get the same answer. So this just gives us another way to check, okay, the summation, being able to rewrite it in a summation form. All right, number 5 is an application. So I would like you to take a few minutes, read this, try to come up with the answer, and then when you're ready, turn the video back on. All right, hopefully you're ready to see the answer. So on part A, they simply want a formula for a sequence. Okay, they want to know nth ring. Okay, if you were trying to find a specific number in a ring, what would you need to use? So that's actually part of the sequence. Now, on part B, they're wanting the total number of skydivers in all 4 rings. So, kind of thinking of a picture, we're starting with the 5 people, and then our next ring is going to double, so the next ring is going to take 10, and then 20, and then 40. They're wanting to know how many total people do you need. Okay, so they're not just saying how many people in the 4th ring. They want to know the total. So that is a series. So 3 ways you could do this. You could do this by hand adding. You could use your formula, or you could use your summation. Okay, all 3 ways would work here, but you should have gotten that you need a total of 75 skydivers in order to complete those 4 rings. Okay, so that is it today. Tomorrow we will look at infinite geometric series. They're a little bit different, but this is where we're going to stop for today.